Okay, this is chapter 25, and we're going to look at just activity-based costing. So this is the last learning objective in the chapter, and it's about how to allocate product costs using activity-based costing. This was actually invented in like the 80s, believe it or not. Okay, most accounting is at least 50 to 70 years old, but this is actually a newer technique. So what it does is it identifies and traces costs and expenses to activities, and from the activity to the product. All right, so that if you've got a product maybe that uses a lot of, let's say purchase orders, okay, just because it's got a lot of parts or something like that, then they would have more purchasing costs allocated to them. All right, or there might be setup costs or inspection costs, anything like that that's like part of the activities that make up the product. This is an alternative approach for allocating overhead when there are diverse products and processes. Like before, we had one big overhead lump, and we allocated it maybe based on direct labor hours or machine hours. All right, now instead of having one bucket, we'll have several buckets. Okay? ABC uses multiple factory overhead rates based on activities. An activity is the type of work or an action involved in a manufacturing process or a service activity. And these are their examples, like assembly, inspection, engineering, design. Now here's an example of that sort of contrasts the two. And you want to keep this in mind as we go forward, but before, the traditional overhead allocation system had all overhead in one pot, and we decided that direct labor hours were about the best cost driver we could have. So we divided all the overhead by direct labor hours and got an overhead rate that we charged per direct labor hour. Okay? And we're saying here that the overhead was $1.6 million. Now what activity-based costing does is it takes all this overhead and says, well, what are you doing in here? Well, we do some fabrication, we do some assembly, and these are machines doing it, okay? It's not direct labor. So fabrication and assembly, we do setup. Machine setup is actually a big job. My father worked in a steel plant in Buffalo many, many years ago, and he actually would do setup on a machine to roll steel, they called it, for 7 hours to get a machine ready to put a cut in a piece of steel. Okay, so that it's a different type of job than what we're used to thinking of, because we don't see that much manufacturing anymore. Then quality control, 312, this might be a bunch of inspections, and engineering change orders. So we take each one of these things and we think to ourselves, well, how am I going to allocate these costs? And so for the fabrication, we're going to allocate it based on the direct labor hours. Fabrication, direct labor hours. Okay? For assembly, we use assembly direct labor hours. All right, so we'll estimate what these are for the year, divide the estimated cost by the estimated usage for the year, and come up with a rate for this particular activity. And that's why it's activity-based costing. For setups, we'll use number of setups. For quality control, we could use number of inspections. And for engineering, number of engineering change orders. So the result is, see, you get a much better idea of what the real costs are for your products. And here's an example. We've got a company here that produces snowmobiles and riding mowers. I guess that makes sense. The company's total estimated factory overhead was $1.6 million. And we've got fabrication was cutting metal to shape the product. And it's machine intensive. Assembly is manually assembling machine pieces into a final product, and this was labor intensive. I don't know why this isn't direct labor, okay, but they're putting it inside of overhead, so we'll just go along with it. Setup is changing the characteristics of a machine to produce a different product, okay, like changing those settings, so that each production run requires a setup. And sometimes, like if you run 10,000 units, it might only be good might only be good for like 2,000, and then you've got to reset the machine and run another 2,000, and then it gets a little bit out of whack. Quality control inspections. This is inspecting the product for conformance to specifications, very important part of manufacturing. And then engineering changes, we get changes in design or process specifications for a product. Okay, those are the types of activities. So the ones that you'll see all the time, you'll see setup costs, you might see fabrication or assembly, and then quality control, you'll see that too. Now here are the estimated activity costs, just like those costs are the same ones that we had here. Okay, so those are the costs per activity. And then here's the activity rate. And the rate has the estimated usage, okay, or cost rather, sorry, divided by the estimated, I can't get it, usage, okay? But those are estimated numbers, and that gives us the rate for the year, okay? I keep saying okay like you can answer me. So for this company, the estimated activity cost of setups is $480,000. And for that, they can do 120 setups, so that means that each setup would cost $4,000. All right, so that's how you'd allocate the cost. So now we've got, let's see, remember we've got 120 setups here. So when we allocate that by product, we've got 100 setups for the snowmobile, 20 setups for the riding mower. There's our 120. Okay, and here are the fabrication hours, assembly, the setups, quality control inspections. So you've got 100 inspections here for the snowmobile. It's a lot compared to 4. And then change orders, they've got 12 change orders compared to just 4 for the riding mower. So that's going to make a really big difference in the costs. This is the example from the book too, if you wanted to read it. Okay, so now we've got our estimated cost and our estimated usage. And there's our activity rate, $53 per labor hour, $7 per direct labor hour, $4,000 per setup, $3,000 per inspection, and then $13,000 for each engineering change order. Okay, see how expensive they are? Those are real expensive. So now this would be our factory overhead cost per unit. And what we've got here is our usage times the rate gives us the cost. This is not as complex as it seems. Okay, I'll do some problems with you and you'll see. You've also done some in Cengage. Okay, so here is our cost for snowmobiles. Okay, our total overhead cost is $12.94 divided by 1,000 snowmobiles. That's $12.94 per snowmobile. And for the riding mower, our total costs are $306 divided by 1,000 units. Would give us $306 per unit. Okay, so that would make a really big difference. So this would be the allocation using ABC. Okay, there's the $12.94 and there's the $306. So just think to yourself, instead of having an estimated overhead divided by the total estimated driver, now we've got overhead broken down by activities, okay? Divided by specific activities, or, activity rates, like the actual fabrication hours, assembly hours, the number of setups, the number of inspections, the number of change orders, okay? And then, using these rates, then we charge it to the product, and it ends up being a lot different. Okay, we're almost done here. So, why this is important is because the allocation of overhead affects product cost. And, right or wrong, we use these costs for decisions like establishing price and also whether to just get rid of a product line because we think we're not making money on it. So if you're allocating overhead according to something that doesn't make sense, then those decisions may not be quality decisions, okay? You might be getting rid of a product that you're really making money on, okay? So using the wrong method can really distort product costs. Here's an example, like that same company uses, let's say they use a single predetermined factory overhead rate, the way we did before, to allocate factory overhead to the riding mower and the snowmobile, and they use direct labor hours. So we had $1.6 million in total overhead right here, and we've got 20,000 direct labor hours. So that would be $80, per direct labor hour. This always happens as soon as I start to record, I start to yawn. Sorry. Okay, so that would mean that riding mowers and snowmobiles would each get $800,000 because they both have 10,000 labor hours. Okay, they use the same amount of direct labor hours, so they would get the same amount of overhead. Okay, but they don't consume overhead in the same way. Okay, when we go back to what they had here, the overhead would have been $12.94 for the snowmobiles, for one snowmobile, and only $3.06 per unit for the riding mower. So like 25%. Oh, this is the one. Yeah. So here's a comparison. There's a single rate method. That's the way we did it before. The traditional method would give us $800 a piece for the snowmobile and the riding mower. But under ABC, it'd be $12.94, a lot higher, and the riding mower would be a lot lower under ABC. Okay, so then you'd have a better idea of what your costs really are, whether or not you're making money on the product. Now this is another company. They've got estimated overhead per year of $600,000 divided into fabrication and assembly. Okay? Oh, 3 things. Oh no, 4 things. Fabrication, assembly, setup, and materials handling. And for fabrication, they're using, the total is going to be 20,000 direct labor hours. Remember, it's divided up between snowboards and skis. 20,000 for assembly. We've got 250 setups, and materials moving is expensive. Believe it or not, it uses up a lot of resources and a lot of time. So materials handling would be 400 moves. Now each product is budgeted for 5,000 units of production, and we want to calculate the activity rates and the factory overhead cost per unit using ABC costing. Okay, so here's for fabrication. I've got 300,000 divided by 20,000 hours, $15 per direct labor hour. Assembly, 120 divided by 20,000, $6 per direct labor hour. For setup, 100,000 divided by 250 is 400 per setup. The materials handling, 80,000 divided by 400, $200 per move. Okay? So it would be a lot less. So that should give you an idea. This is a little bit longer than I wanted to go of how it works. Let's work a couple of problems and look at some definitions so you're ready. Okay.